Hi girls, so I want to talk to you about the second derivative in this video, and I'm going to do a little bit of cheating in terms of doing some calculations and things very quickly, but I hope you'll just trust me. So I'm going to start by drawing a cubic function, and I'm just going to pick one to make the numbers very nice, and I'm just going to pick the one that has roots at -3 and 3, okay? And it turns out that with not too much work, you could check that this is the equation of my function, and that's the one I'm going to talk about. So now I'm going to take the derivative of that, and I'm going to do it by drawing it. So I'll draw it in red. So the derivative is going to be 0 there, 0 there. It's going to be a parabola, so I know it's going to look something like that. And again, without too much work, you can see that it's 3 outside of x squared minus 3. Okay, which means you can calculate the value of the x-intercepts if you wanted to, but I'm actually not particularly concerned about that. So remember when we drew the derivative, we said, well, over here, the function is increasing up until this point here, which is a stationary point, at which point it's decreasing, and then from here to here it's also increasing. And notice where I've highlighted yellow that the parabola is above the x-axis, and then if I were to highlight in a different color, let's say green, then through here the function is decreasing, and that's where the parabola is below the x-axis. So now on top of this, I'm going to draw the second derivative. Okay, so I'm going to draw the second derivative as the derivative of the parabola. So that's a straight line, and you can see that at the origin, at x equals 0, the parabola has its vertex. So it's a straight line through there. And again, ignore some of the details, but it's fairly easy to see that the second derivative takes the value 6x. Now what I want you to think about tonight for me, and hopefully come to me tomorrow with questions, is what's happening at the various segments of this. So what's happening when the second derivative is negative? Right, that's all this stuff, right? That's where the second derivative is below the x-axis. What can you say about the original curve when the second derivative is negative? Anything at all you can say. What can you say about how the curve is changing? What can you say about the shape? What can you say about the curve at all in that segment? Same thing over here. What can you say about the curve when the second derivative is positive? Now, the way I want you to think is that the second derivative is the derivative of the derivative. So it's how is the slope changing? So in this section over here, if I'm just thinking about the original function, if I draw a tangent, the slope is positive. But then if I draw another tangent over here, the slope is also positive. But how does it differ? How do the two slopes differ? And how does that relate to what's happening in the second derivative? Same over here, right? Positive slope here, positive slope here. Remembering that when I'm talking about change, I'm always talking about moving positive on the x-axis. So positive slope, how does that change as I go from there to there? Right, that's what I want you to be thinking about tonight for me as we think about the second derivative, and I'll give you some more details tomorrow. I'll see you then. Have a nice night.